This will be the first lesson reviewing the textbook for our course Math 1108. And hopefully we have some sort of booklet that you can follow this in. And as we go along, take notes, neat, orderly notes on what we'll be talking about. Now, generally I will not be reading the textbook to you, but sort of highlighting what is in the textbook to serve as a basis on which you will build your mastery of the various rules in math and the examples used to support that. So, we're going to start off on topic 1.2, polynomials. Poly means many numbers. And we start off with a shorthand notation that if we have, for instance, 5 times 5, and we want to write that in a special way, we take the 5, which will serve as our base, and then we use a supercase number. The number of times 5 is used as a factor. This is called exponential notation. So 5 squared, or 5 to the second power, means this. 6 cubed, or 6 to the third power, means this. And generally we write it in this form. A is our base, and the n is the exponent. So, going on to example 1, this is 4 to the 6th power, and generally we put that in our calculators, and we're able to use this technique, 4, and then in your calculator there's a little mark that's called a caret. Not like the one that the rabbits eat. This is a shorter version. C-A-R-E-T. Caret. And then we just enter the number 6, hit the equal sign, and it gives us this answer. And the calculator does all that. Now, similarly, when we see something like this in parentheses, our base now includes the negative sign, and this is to the third. So we have the rule negative times negative times negative gives us a negative. Having a base an odd number of times, if it was negative originally, is negative. If this would have been 5 to the negative 5 to the 4th power, that would be an even number of negatives. That would have ended up being a positive 625. But when it's just 3, the negative holds, and negative times negative is a positive, times negative is a negative. Okay, example 2, we're using a calculator to approximate the given expressions. And when you do that, you get this. And in letter B, again, you put all of that in parentheses, put a caret sign there, 23, and it's approximately this. Now, keep in mind, and I like the way the textbook does this, is they're saying if you have something like this, you do not multiply the 4 times 3 first. That is, you do the exponents first. And you may remember that order of operation. Please excuse my dear Aunt Sally. So, grouping symbols, parentheses, exponents, these are done first. Then we do multiplication, division, as we come to it from left to right, and then finally addition, subtraction. If subtraction were first, we'd do that first. If division were first, we'd do that first. And again, you'll have your practice. Now, another important point we want to bring out here is that when you have -4, well, let's try that one again, -2 to the 4th power, what is your base? Is it the -2 or just the 2? And the answer is it's just the 2. So then when you square the 2, you get 16. Then you apply the negative sign. Now, different is if the negative sign is within the parenthesis. Now that is a -2 as your base. So when this is squared, we're going to get a positive because we're using that negative sign 4 times. And that gives you a positive 16. They're illustrating that. Again, taking time and going to the online textbook, which is what I'm using here, is an excellent source of information. And of course, you can read it as slowly or as quickly as you want. But this is going to be our general presentation. So by definition, 3 to the 4th power is you write 3 out as a factor 4 times. 3 to the 2nd, you write it out twice. How many 3's do you have? 6 altogether. So shorthand, 3 to the 6th. How do we get that from there? Well, the rule is, as you see here, we add our exponents. So when we're multiplying variables or numbers with exponents, as long as the bases are the same, we just add the exponents. So in example A, here we have a 4 and a 6 that we'll add together and get 10. A 3 and a 5. Remember, our bases are the same. And we get, in parentheses, -2 to the 8th. Again, what is in parentheses? We just add the exponents. And even if it's a binomial, like 2 terms within a parenthesis, this is to the 2nd, this is to the 5th, we just add the exponents. Now, another rule we have that is sometimes confusing for students is what we call the power rule. Now, the power rule, we have, let's say, a to the m, but now we have parentheses around that, and then what's in parentheses we now raise to a power. Here, we don't add them, we actually multiply them. And no sign between them implies multiplication. So as we look at example 4, we're going to multiply. Because what is this? This is x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. So if we strung it out like this, we'd see there are x to the 12th. There would be 12 of them. And a shorthand way, instead of adding, we can multiply. We have 4 of these, so 4 times 3 is 12. Here, 3 times 5 is 15, and 4 times 4 is 16. Again, you'll have these examples, and of course, practice in your math lab. Moving on. We will be going over this shortly. Here we're dividing something by itself. Now, whenever we do this, we know anything like 5 divided by 5 equals 1. Well, if it's in this form, we have a rule which is called the quotient rule, in which we take our exponent from the bottom. Again, bases have to be the same. Bring it up across this division bar and subtract it from that exponent. So this is going to become a to the 0 power. 3 minus 3 is 0. Now we also knew that anything divided by itself is 1. So we introduced the rule that anything to the 0 power is equal to 1. And we see it here, and we see it worked out there. All of these, by the way, are 1. This is a 1. This is a 1. This is a 1. Now here, because of the parentheses, 12 to the 0 power is 1. But now we have to apply the negative sign. So this one could be a little tricky. This is a negative 1. Now if the parenthesis contains the negative sign, as we see in letter C, that's a positive 1. But here the base is only the 12. That is to the 0 power. Then we apply the negative. Now there is an exception to this, by the way. 0 itself. 0 to the 0 power is not 1. Just as 0 divided by 0 does not equal 1. This is not defined. Anything divided by 0 is not defined. Now, when we look at polynomials a little more quickly, or less quickly, I should say, once again, anyway, these are algebraic expressions that are separated by positives in some cases. In some cases, you might have a negative in there. And these items that are separated by a positive or sometimes a negative are called terms. We think of the terms in a polynomial. Now, these terms, as we see 5x to the 4th, part of it is a variable, that is a letter representing something, and in this case it's exponent. And we also have, in most cases, showing a numerical part of that term. Well, this numerical part is referred to as the coefficient. Okay? So here the coefficient is 5, a 2, and a 6. And it's what's in front of each term. A tricky part sometimes, as we see down here, where there is no number, well, we don't write it usually, but there's a 1 in front of anything. Okay? So they want to identify the coefficient and the constant term. Well, the coefficient here is 5, here it's -1, and the constant term is 12. And for letter B, it's 7, a 2, as the coefficients, and the constant term is -4. So in looking at this little chart, in summary, if we put it in descending powers of our exponent, we have what is called a leading coefficient. In this case, it's the coefficient on the highest power, and that is 6. Here, the leading coefficient, again, it's a -1 x to the 4th. So our coefficient there is a -1, and that's the highest power. Here, again, when there's no number, there's a 1 there. And this is a constant. Now we're taking a look at another term too, which is called the degree of a polynomial. And the degree of the polynomial is the sum of the exponents on the variable in the term that we see, and it's the highest one. So here we see the degree of this is 7, the degree of this one is 3, this one's 2, this one's a 1, and here there isn't any, so that's 0. So the highest degree of any term in a polynomial is the degree of the polynomial, which in this case it's 7. In this case, looking at them, it's 4. Here it's 3. And since there is no variable, we say it's to the 0 degree. And the term without a letter we think of as the constant term. So you'll have some practice on this as well. The degree of a 0 polynomial, again, is not defined. Now, anything to the first power, where you have x, let's say, to the first power, this is what we call a linear polynomial. If you have something to the second power, this is called a quadratic, and to the third power, this would be a cubics, respectively. Okay, we're going on now to addition. Now, when we do addition and later subtraction, we are only dealing with what we call like terms. A like term, by definition, has the same variable and the same exponents. And when we do that, we only add the numerical coefficient part. Here they're the same sign, so it just becomes 18 y to the 4th. Here this 2 is a negative 2, so you get a negative 2 plus 8 gives you a positive 6 m squared. Again, the variable portion does not change as you do the addition or subtraction. In our textbook, they're showing us a strategy now for adding like terms, where we reorganize them into horizontal groups of like terms, and then doing the actual addition. I like the strategy of putting them into vertical like term columns. And of course we've easily identified now our like terms. So this will be 11x to the 3rd. This is going to be a positive 1x. We don't write the 1. This is going to be a negative 3x, and then plus 8. So you get the same answers. It just looks to me that adding them up vertically, although knowing the technique horizontally is good as well. Okay, and B is just a similar way. Going over some other basic rules for eliminating parentheses. If there's no sign in front of the parentheses, you can just eliminate it. If there is a negative sign in front of parentheses, the rule is remove the parentheses, but then change each of the signs. This was positive, it's going to become negative. This is negative, it will become positive. This was positive, it would become negative. Now you don't have parentheses anymore, you just group like terms. So we have an example there in 7. And that's pretty straightforward. Again, change each of the signs, group like terms, and add them. In example 8, now we're using a technique that's called the distributive property, where we take each example, in this case there's 3 terms, and multiply it by what's out in front, carefully distributing that. Now later we're going to have answers like this, and we have to reverse the process. It's called factoring. We go from this back to that. Now when we have 2 terms multiplied by a 3-term group, we take the monomial from the first binomial and then multiply it by each term of the second grouping, and then take our second term from the first binomial and multiply it by the second, in this case trinomial, and then group like terms. So this will be a technique that's pretty straightforward, and this, by the way, can also be done vertically. Now if you're multiplying a binomial by a binomial, again, you take your first member, multiply it by the second, take your second member of the first, multiply it by the second, group like terms, and then eventually you get a trinomial. But they will be introducing what is called the FOIL, and we'll go over it right now. Now the FOIL is just an acronym for a way to multiply this. F is for the first terms. O is for the outer terms. I is for the inner terms. And then last is for the last term in each binomial. So let's do that. 2x times 3x is 6x squared. The outers now are a positive 8x, inners a negative 15x, and then last a negative 20. Notice we have our 2 like terms in the middle, so we summarize now. Grouping like terms, this will be a negative 7x minus 20. Okay, so we anticipated that in the FOIL, and of course you'll have examples to do here as well. But I do want to mention 2 special products here. This one, in which we square a binomial. Now, this you can expand into 2 binomials like this and FOIL it, but there is a special way to do it, in which we square the first term, multiply these 2 together, get a positive 3x, and then double it, which gives us a 6x squared. And then we square this. And this is what is called a perfect square trinomial that we get from squaring a binomial. And this one too, and we did many of these in our Math 1103 course, that if you have something like this, 2x plus 1 and 2x minus 1, we say this will be the product of the sum and difference of the same terms. And these have a special name. They're called conjugates. And I like this word, write it down. And when you multiply conjugates, an interesting thing happens. Let me FOIL this for you. this will be 4x squared minus 2x plus 2x. That was the outers and the inners. And then minus 1. Notice your two middle terms cancel each other out. So you end up with 4x squared minus 1, which is the difference of perfect squares. And the difference of perfect squares, we will find out, factor into their conjugates. Now in this part, they're introducing us a little background of business. And then later in chapter 3, we're going to go into this big time. But right now, some beginning stuff. This is function notation. And we say that c of x is what is called a cost function. And r of x is called the revenue function. So when you make a particular item, like stationery, you need the paper to make that package of stationery. Well, this is going to be a cost right here, which is the amount of money needed to make that particular item. Now also, along with the paper, you need some sort of machine, a printer or something, and that's going to be a big cost. And over here, that's what we call the fixed cost. Now, when you sell that stationery, you're going to keep in mind what it cost you to paper and then a part of that machinery and everything, and you're going to sell it for more than what you, of course, need to produce it. So let's say your paper cost is like $1.50, and you're going to sell it for $4. And that's what it is. And the cost of the machinery over here was, let's say, $3,000. So your costs are the paper and things to make that stationery, and then the printer to produce the stationery on. And to some extent, you have to think of the employees and other things, but we're trying to keep this just basic here. And then this is what, when you sell a package of stationery, you're going to take in. And they give us an example here. Now, here's our formula. How much money would you produce if you sell an item for $12 each? So here you're going to put $12, okay, and you're going to sell, let's see, 150,000, okay. And operation costs are this, and to make a particular item is this. You put this into your formulas here and sort of crank them out. And we need one more formula before we finish this up, and that is the profit formula. Again, profit is equal to revenue minus the cost. So if we take the data that's provided on the previous page, put it in there, we get then what our profit is. And of course you'll have your practice in quiz maze.